Hi, welcome and let's learn VPN. So in this lab, we are going to learn GRE over IPSec. So GRE is the generic routing encapsulation, while IPSec is IP protocol security. GRE has its own advantages, while IPSec also has its own advantages. So we are going to integrate the advantages to come up with GRE over IPSec. So GRE provide a tunneling protocol where we can protect the multicast and the broadcast traffic, not only IP packets, while the IPSec only protect the IP data. So here, when we use GRE over IPSec, we are going to protect both the multicast and the IP data. So GRE and IPSec complement each other nicely in that the IPSec offers confidentiality, integrity, and authentication, while the GRE offer the ability to tunnel traffic, which IPSec cannot provide alone. So we are going to look at the lab scenario. In our lab scenario here, the networking requirement here that the enterprise wants to protect traffic, including multicast data, between the headquarters and the branch. As IPSec cannot be applied to multicast data directly, GRE over IPSec can be established between virtual tunnel interfaces to protect the traffic on tunnel interfaces. Let's look at the topology. So this is the topology where we are going to create a GRE over IPSec, and also we are going to create a virtual interface, that is the tunnel interface, on router A and router B, where router A is on a branch gateway and router B is on the headquarter. Let's say, for example, you are an employee of a company, but you want to work from home. We'll have to log in into your network through a secure protocol, where here the secure protocol we're going to use here is going to be the VPN. So let's just begin. On this our router here, we are going to make sure that PC1 here can reach PC2 here. So we are going to ensure there's a layer 3 communication between router 1 and router 2. So on router 1 here, we are going to configure the interfaces and give them IP addresses. So interface gig 0/0/1, IP address is going to be 1.1.1.1/24, and the interface that connect to PC1 is going to be interface gig 0/0/1/2. Give it IP address of 10.1.1.1/24. Then on that same router, we're going to create a virtual interface, that is the tunnel 0. So interface tunnel 0/0/0. We give it IP address of 192.168.1.1/24. Then you do the same to the router on the internet. Router on the internet, we're going to give them IP addresses. So interface gig 0/0/1, give it IP address of 2.1.1.2, subnet mask of 24, and interface gig 2, we're going to give it IP address of 1.1.1.2/24. Then you come also on router 2 here, you give it IP addresses. So interface gig 0/0/1, give it IP address of 2.1.1.1/24. Then also you enter gig 2 that connect to PC2, and gig 2 give it IP address of 10.1.2.1/24. After that, the next thing we do after configuring the interface IP addresses, we are going to ensure also we are supposed to create also a tunnel interface between router 1 and router 2. So on router 2 also you enter interface tunnel 0/0/0, give it IP address of 192.168.1.2/24. Then we are going to make sure that router 1 here and router 2, their routes are reachable, so that while you are on router 1 here, you can ping interface on router 2. We're going to configure static route from router 1 to router 2 here. So we're going to tell this router here the network where 2.1.1 belongs. So on that router, quit. So IP route static. IP route static, we are going to tell it a network of 1.1.1.0, wildcard mask of 20, not wildcard mask, subnet mask of 24. Then our next hop is going to be the router on the internet, that is 1.1.1.2. Then also, while on router 2 here, I'm going to configure two-way IP route, so quit, and also give it the network. We tell it the network of 1.1.1. So IP route static 1.1.1.0, subnet of 24. Then the next hop will be 2.1.1.2. That is the interface on router on the internet. After that, let's see if we can now reach that router 2. So while on router 1, try to ping 2.1.1.1. So you can see the packets are able to go. So meaning that route is reachable. The IP route has been set up. Also ensure that also these switches have been given, these PCs have been given IP addresses. So come on PC, and you can see it has been given IP address of 10.1.1.2, and its gateway will be 10.1.1.1. That is the interface that connects to router 1. Also come to PC2 here and see if it has been given an IP address. It has given an IP address of 10.1.2.2, and its gateway is 10.1.2.1. And let's see if these routers can reach each other. These PCs can reach each other. First of all, we are going to ping 2.1, the gateway for router 2, 2.1.1.1. It can't reach because still it doesn't know about that network. But by the end of this chapter, after we configured the tunnel and we've configured a route on the tunnel to reach the network that is going to be protected, that's when PC1 and PC2 will be able to ping each other. So we continue, and the next thing we are going to just go straight away to configure the VPN now. So IPSec, start with the IPSec VPN. So IPSec proposal. The proposal here, we're going to give it the name of SmartNet 254. After that, we give it the encapsulation. So create a transform. The transform here is going to be ESP. Then ESP authentication here will be, we have got different types of authentication. Let's see. So we have got MD5, SHA-1, SHA-2, 256, SHA-2, 384, and SHA-2, 512. SHA-1 and MD5, these one are not highly protected, so it's advised that you always use SHA-2, 256 going onwards. MD5 and SHA-1 are not that protected, so when you want to ensure that your VPN is highly protected, use SHA-2. So here we're going to use SHA-2 256, and also ESP encryption algorithm. And look at encryption algorithm. The modes here, we have got 3 triple DES, and advanced encryption standard, advanced encryption standard 128, advanced encryption standard 192 and 256. So for triple DES and DES, those are not secured, so we are going to use advanced encryption standard 128. So use advanced encryption standard 128. After that, we are going to create the encapsulation mode. So encapsulation mode here will be a tunnel. Make sure it's a two-way. So you also come on router 2 here. You create an IPSec proposal. So IPSec proposal here, we're going to give it the name of SmartNet 254. And the transform you're going to create is ESP. After that, you tell it encryption, authentication, algorithm here, we are going to use SHA-2, 256, then ESP. Encryption algorithm here will be AS128. Encapsulation mode here, we are going to use tunnel encapsulation. On router 1, we are going now, after that, we are going to create the mechanism through which router 1 and router 2 will be able to exchange the keys. So we use IKE, that is Internet Key Exchange, where we employ a digital, the automatic, which is called Diffie-Hellman. So Diffie-Hellman is an automatic way in which you can exchange the keys, while you can either configure it in a Diffie-Hellman or a manual mode. But with the manual, it's more complex and also it's very costly. So we are going to use the automatic way, that is Diffie-Hellman. So on that, you create IKE proposal here. We are going to use number 5. On IKE proposal here, that's where we are going to give it authentication. Here we're going to authentication algorithm will be SHA-1. Then encryption algorithm will be advanced encryption standard 128. After that, you give it, because we said it's not going to be manual, we said we are using Diffie-Hellman. So say Diffie-Hellman DH, then group, you're going to give it, you have how many groups? Let's see the number of groups we have. So we have group 1, group 14, group 2 and group 5. So we give it group 14. After that, you quit, and also do the same on router 2 here. So create IKE proposal here, we said you set number to 5, and authentication algorithm here will be SHA-1. Encryption algorithm will be advanced encryption 128. Then if Hellman group will be group 14. After creating an IKE proposal, the next thing we do is now configure the password. That is the password that the peers should be able to exchange and also be able to enter and receive the packet. So IKE peer name here, we're going to give it smart. Then version, I'm going to use version 1, but remember that version 2 is more advanced, because in version 2 you can also configure an IP packet, but with version 1 you can't configure IP packet. So enter, but here we're going to use version 1 for a demonstration. So version 1, on version 1 we set the password here cipher, and we set password to Huawei to 1, 2, 3. After that, we are going to bind the proposal, the IKE proposal that we created earlier. So IKE proposal 5. Display this. So here is where you also can configure the remote IP, but with IPSec. With GRE over IPSec, we don't need to configure a GRE, because we are going to establish a profile. With profile, it can't accept the the remote IP. So you just quit and also do the same on router 2 here. You quit and create an IK peer. Name will be a smart version 1. After that, you create the password, preferred key, cipher here. You said Huawei. Make sure the password is the same. If you configure wrong password, it won't be able to establish that channel. So Huawei at 123. After configuring that password, we are going to bind the IK proposal that we created, that is 5. Then you quit. Go back to router 1. On router 1, quit, and here we are going now to create a profile. So that is, we are going to create an IPSec profile that is going to carry the IKE and also IKE peer and also the IPSec proposal. So create IPSec profile here. Then you create a profile name. So profile, yeah, let's use profile name 1. After profile name 1, we bind the IKE peer. IKE peer, we said it was smart. Then we bind the IPSec, the proposal. IPSec proposal here. Proposal we said was SmartNet 254. Then you quit and you do the same. You do the same to router 2. On router 2 here, you enter IPSec profile. Name here is going to be profile 1. And under profile 1, we're going to bind IK peer. Name was smart. Then we bind the proposal. Here, name was SmartNet 254. After that, you quit, and we are going to bind the profile on a tunnel interface, the GRE tunnel. So before binding it to the GRE tunnel, we're going to ensure that we create a GRE tunnel. So interface tunnel 0/0/0. We're going to create now the GRE tunnel. Display this. You can see that tunnel 0 has an IP address. So we are going to create a tunnel protocol here. Is going to be a GRE, that is generic routing encapsulation. After that, so on this GRE tunnel, we are going to tell it the destination and also the source. So the source, we said the source will be 1.1.1.1.1. Then the destination will be at the interface on router 2, which is 2.1.1.1. Display this and see what you've configured. You can see what is on that tunnel interface. On router 2 here, you also configure the same for the tunnel to come up. So interface tunnel 0/0/0 display. When you display and see if it has an IP address, so it has an IP address. So configure the tunnel protocol to be GRE, and the source address will be 2.1.1.1, while the destination address will be 1.1.1.1. that is on router 2. So after creating the tunnel, you confirm if the GRE tunnel is up. So you quit and you confirm that GRE tunnel. So display tunnel info statistics and see You can see here one GRE tunnel has been created. So one GRE tunnel has been created. So that is tunnel 00. So meaning that we've created the GRE tunnel. So after that, what we are going to do, we are going to bind the, see if we bound a display. So enter interface tunnel tunnel 0/0/0 and display this. When you display this, you can see what has been configured onto that tunnel. So we are going to bind the profile that we created, the IPSec profile that we created on this router here. That is going to help create the tunnel, and also the tunnel to be over GRE to be over IPSec. So now we are going to bind the IPSec into the GRE tunnel. So IPSec profile here, and we give the profile was 1. After that, also on router 2 here, enter interface tunnel 0/0/0 display, and see if we've configured it. On this one also it's not configured, so configure IPSec. We bind that IPSec profile into that tunnel interface. So profile here is profile 1. After that, the next thing we are going to do is, now we are going to configure the static route on the CAPWAP tunnel to protect the networks of PC1 and PC2. So on router 1, we configure static route to the network where these PCs belong. So on router 1 here, we're going to configure that the static route on the IPSec tunnel and create IP static route. Here the destination will be IP route static, with the destination going to be the network where PC2 belongs. So 10.1.2.1.0/24, while the outbound interface is going to be tunnel 0/0/0. Also on router 2 here, we are going to configure the static route with the network that is to be protected. So IP route static here, the network we are going to protect is for PC1, so that is 10.1.1.0, while you can subnet mask of 24, with the outbound interface we being tunnel 0/0/0. After that, PC1 now should be able to ping. So while on this router, let's try see if we can ping PC1. So ping 10.1.1.2. So it's able to reach each other. So also on PC1, let's see if now we can ping PC2, because initially back then when we tried to ping PC2 from PC1, the packets was not being able to go through, because PC1 didn't know where PC2 belongs. But now let's see if it can ping. Let's first of all ping the gateway. It can reach that gateway where router 2 is. Then now ping PC2. So ping 10.1.2.2. It's able to reach PC2. Let's see if it's a two-way. While on PC2, let's ping PC1. So ping 10.1.1.2. And it's able to reach PC2, meaning that the link is active. Now let's see if our tunnel is up. So if our IPSec over GRE over IPSec is up, so display IKESA. When you display IKESA, you can see the peer here. We are being told that the peer is 2.1.1, and that's it, guys. So that's how you can configure GRE over IPSec VPN. Thank you for watching the video, and stay tuned for more of our labs.